Hello, my name is Emily Nottingham, and I'll be discussing how to evaluate the inter- and intra-annual variation in soil moisture throughout the Great Plains region. I'll begin with the water budget, as it is the fundamental equation that has been used by scientists and land managers to determine the amount of water that is available to use. This equation consists of inputs in blue subtracted by the outputs in green to determine the change in water storage. Throughout the years, we've been able to measure and calculate the inputs and outputs of the system, but what water is stored in the soil has always been estimated, even though it is the most important variable because it drives other hydrologic processes such as the partitioning of rainfall between runoff and infiltration. It determines how much water is needed to be irrigated, and it can influence precipitation events through land-atmosphere interactions. However, recent advancements over the past decade in satellite and modeling technology have shifted soil moisture from being estimated to being globally collected and analyzed. An example of this technology is the Sport LIS software that produces 0 to 10 centimeter surface soil moisture values at a coarse resolution of 3 kilometers. This technology has shifted our ability to measure soil moisture from a single point scale to estimating at a field or watershed scale to now having coarse soil moisture details for large areas that had otherwise not been possible. This is important because water resource decisions are made throughout these differing scales. So, to better understand this large areal resolution, I will evaluate the inter- and intra-annual variations in soil moisture throughout the Great Plains by using the Sport LIS surface soil moisture values and a program called TimeSat, which determines what time of year the soil profile is full of water and when it's at its driest, along with the corresponding rate at which it wets and dries. After this, the BFAST algorithm will be used to evaluate the seasonal and annual trends in this data. From this, there will be a better understanding of the soil moisture variations throughout the Great Plains, which can help scientists and land managers to make decisions in relation to reservoir management, irrigation applications, and farming practices. This is especially important as climate change impacts are expected to cause increased demands for water and energy within the Great Plains region, and can result in shifts from irrigated cropland to dry land farming, which can further cause serious impacts on the global economy and global food security systems, since more than 30% of the U.S. agricultural land area, along with more than 30% of the beef production in the United States, is located within the Great Plains region. Thank you.